Hi everyone, myself Dr. Arun. Today we are going to discuss about mediation device protocol. This is the one of the type of MAC protocol in wireless sensor network. So in this video we know that various types of MAC protocols are available in wireless sensor network. So based on low duty cycle protocol and wake up concept, two protocols are represented. One is SMAC protocol and mediation device protocol. Next one is contention based protocol POMAS. Next one is schedule based protocol LEACH. Finally IEEE 802.15.4 MAC protocol. So in this video specifically we are going to discuss about mediation device protocol. So in the mediation device protocol allows each node in the wireless sensor network to go into sleep mode periodically and to wake up only for short time to receive the packet from the neighbor nodes. The above approach will eliminate the ideal listening problem in wireless sensor network. The mediation device protocol is compatible with the peer-to-peer communication. In this mediation device protocol, there is no global time reference will be maintained in the entire network. Each node has own sleep schedule and does not take care of neighboring sleep schedules. In each period of wake up, a node transmits a short query beacon to other nodes. The query beacon indicates its node address and its willingness to accept the packet from the node. So you can see the scenario. The three nodes are available. So one node is wake up condition. Immediately it will transmit a query beacon to nearby the nodes within the coverage area of this particular specific node. So then it will wait for some time, that is called it will open a window to receive a packets from the other nodes. If no other packets are received, immediately it will move to sleep mode. So during this sleep mode, if some other nodes are trying to transmit a packet to this particular node, the node will not accept. So then there is a problem in this particular situation. We must synchronize the corresponding between this particular transmitter and also the receiver. So again we are unable to communicate between transmitter to receiver. It will not deliver any packet. So this particular problem is eliminated by using mediation device protocol by introducing a mediator device. The mediator device used to synchronize between the transmitter and the receiver, because the transmitter and the receiver having its own sleep time and also the wake up time. So in this particular sleep time and wake up time of both transmitter and receiver is synchronized by using the mediation device protocol. That means your mediation device. So this mediation device always active and receiving the information from the transmitter and also receiver. Based on the request, it will synchronize both transmitter and receiver sleep time and wake up time for the transmission of the information between transmitter and receiver. The mediation device is not energy constrained and can be active all time. So now we can move to the exact algorithm. We can take one scenario here. The node A is available. This node A acting as a sender and node B is acting as a receiver. This MD, this is called mediation device, or this particular node is acting as a mediator. So now A wants to transmit the information or packets to receiver. So in this particular scenario, the A will transmit a corresponding RTS packet to mediation device. The RTS packet means we know that request to send. So A is having some set of information. That information wants to transmit to B. So in this situation, we don't know the exact sleep time and wake up time of the B. That's why just we are giving the request to mediation device. So first we are sending the RTS packet to mediation device. So the mediation device stores this information, then waiting for the beacon or query from this corresponding B. So the B is sending a query to mediation device at periodically when it wakes up. So immediately the mediation device recognize already there is a request from sender A. So then based on this query, the mediation device gives the response that is called query response. So in this query response, the A address and timing offset will be communicated to the B node. So then the B node will recognize this corresponding query response. Then it will wake up and adjust the corresponding wake up time and sleep time, and based on the corresponding A node wake up time and corresponding sleep time, it will send clear to send CTS packet to the sender A. That is the next process. So once this clear to send is received by A node, then it will start transmitting the packets from A to B. So once the packet is received, immediately the corresponding node will send an acknowledgement to A node. This process will repeat till the completion of all the packets. Once all the information is communicated from A to B, so then it will break the corresponding synchronization between A and B. That means the node A and B restore its own periodic cycle and thus decouples from A's period. So it will be discontinued. It will move to their own actual natural periodic schedule. So then the advantages of this corresponding mediation device protocol. This protocol does not require any time synchronization between nodes. Only the mediation device has to learn the periods of the node. So that means this synchronization completely taken care by only the mediation device. The individual nodes will not bother about the synchronization among the nodes. The protocol is asynchronous in the sense or the most of the energy burden is shifted to mediation device. That means the entire energy burden will be transferred to mediation device because the mediation device is completely wake up period only, completely active during the entire process. So that's why the energy burden is completely transferred to the mediation device. The other nodes can be in the sleep state most of the time and have to spend energy only for the period of beacons. The mediation device will do the synchronization work between the sender and receiver. In this way, very low duty cycle can be supported. Similar manner, this particular protocol having some disadvantages also. The node transmit their beacon without checking for ongoing transmission. So some transmissions or packet transfer is going on between two nodes without awareing that particular information. Some other nodes also trying to transmit the packets to that specific node. The beacons of different nodes may collide when the node has the same period and their wake up periods overlap. So if the wake up periods are properly randomized and the node density is sufficiently low, this collision problem can be low. So however, in the case of higher node density or unwanted synchronization between the nodes, the number of collisions can be significant. So whenever the collision occurs in the network, the mediation device emitted a dedicated reschedule control frame to the entire network to make the corresponding nodes, the corresponding the periodic sleep and wake up period will be adjusted and eliminate the collision. There is a sufficient mediation device to cover all nodes. There is the next problem. This distributed mediation device protocol deals with these problems in the probabilistic manner. So as a single node acting as a mediation device, it is very difficult to maintain a synchronization within the cluster. So we need more than one mediation device. So then only the maximum data transmission will happen within the network. So at the same time, the corresponding mediation device itself taking care of all synchronization, soon that particular node power will drain up. This is another problem in the mediation device protocol. So I think this particular video useful for you. Thank you for watching this video. So kindly like, comment and share, subscribe. Thank you all.